So, whenever you look at a piecewise function, if we kind of look at how it's broken up here, you have this rule goes for this part of the graph. So this is x is less than 0. So if you think about making yourself a vertical line right there at 0, where x equals 0, it is going to be everything less than 0. So it's going to be this part of the graph right here, and that would have an arrow in, follows that rule. And if you remember things about negative x minus 2, that is a linear equation. If you remember y equals mx plus b, it has a slope of negative 1. It has a y-intercept at negative 2. It's this piece of the graph right here. So if the x value you're plugging in is less than 0, you're going to use that part of the graph. Then we've got another piece of the graph. We got 2 minus x minus 2 squared. That's going to be a parabola. I know it because of that square right there. And we're only going to use it from 0 to 4. So I already have a vertical line at 0 right here. I'm going to put myself another vertical line right here at 4. And you can see that this is that piece of the graph. I realize this was already blue up here, but yours is not colored. And that's that piece right there between 0 and 4. And then the last piece of the graph right here is whenever x is greater than 4. So we already put our vertical line at 4. It's going to be everything to the right of 4. That would be this piece of the graph. So with a piecewise function, and we're going to do this in a second whenever we actually want to graph a piecewise function, you are sort of chopping up your graph and putting those pieces of that graph together. Now this particular graph all connects together. They don't always do that, and we'll look at some that don't, but all of the pieces connect together for this graph. Yes. Thank you. All right. Okay, so let's talk about how to evaluate a piecewise equation. We're going to do it both from a function and from a graph. So, first of all, very important here, you should only get one answer, okay? What a lot of kids do is they just start plugging 4 into every equation and they give me 3 different answers for this. That is wrong. You should only get one answer, okay? So when it asks you to find f of 4, you should only get one answer. So don't just plug it in to everything that is here. So if I have f of 4, the first thing you have to do is decide which function to use. So you are not looking over here, you are looking over here. Is 4 less than 0? It is not. We are not using that top function here. What about 0 less than or equal to x less than or equal to 4? Does 4 fit here? It's a little confusing because down here we got x is greater than 4, right? Is 4 greater than 4? It is not. The or equal to sign is right here with this middle equation. So when we're doing f of 4, we're going to say, oh, 4 falls in this segment right here. So that means we need to use that middle equation. So when we're evaluating this, we're just going to plug in 4 for our x, but we only use that middle equation. Okay, so you got to choose which piece to use first. And then you're going to evaluate this just like you normally would. You're going to have 2 minus, this will be 2 squared. You have to square this. So 2 minus 4, and we're going to get negative 2 for that. Now, this equation is the same equation as the one on the slide before. So I'm going to flip back there. I plugged in 4. I got out -2. What that means is the point where my x is 4 and my y is -2 should be on the graph. So let's go over here and make sure that's the case. At 4, -2, right there, that point is on the graph. So that lets us know that we did it correctly. There. Okay, questions there? All right, so if I am looking at the next one, I've got to decide which function to use for 0. A lot of times they're going to ask you about these like cutoff points, the places where you switch from one function to the other, because those are sort of the most interesting points of the graph. So if I'm looking for f of 0, which function should I use? The top, the middle, or the bottom? See, I would narrow it down to either the top or the middle, because both of those have something to do with 0. For that, Joey, is 0 less than 0? It is not. Would 0 work here? 0 less than or equal to x less than or equal to 4. It can, because we got an or equal to with our 0, right? So that can be equal to 0. So again, we're using the middle function on this one. So we're going to do 2 minus, we're plugging in 0 for our x here. And so we've got -2 squared. And that's going to give us -2 as well. And that's, I plugged in a 0. I got a -2, so that means the point 0, -2 should be on the graph. So if I flip back over here real quick to my graph, 0, -2 is in fact right there, a point on my graph. So that lets me know I've probably done it correctly. Okay, last one here. I've got 8. So for this one, Jose, which function would I need to use for 8? The top one, the middle one, or the bottom one? That bottom one, because 8 is greater than 4. So I'm going to do just -1/2 times 8. Whenever you're multiplying by a fraction like that, it's just finding half of 8. So we're going to get -4 for this. And if I want to check to make sure that that looks right, I would see if 8 -4 is on my graph. So if I flip back over here, 8 is here, oh wait, 5 is here, 6, 7, never mind, 8 is here, -4, that is in fact on my graph, so that looks good. Okay, questions? Okay, let's talk about how to do this if you only have a graph. Okay, so here the graph h of x is shown here, and if I only have a graph, then I need to be able to evaluate this just from the graph. So I can't plug in the numbers here because I don't have the functions. So I would have to just go from the graph. So if I want h of 2, that means my x coordinate is 2, and I need to find the y coordinate that goes with it. So my x coordinate is 2 right here. I go up here to this point on the graph. What is the y coordinate there, Heston? It would also be 2, but we're looking at the y-axis there to find that 2. So 2 is my answer. Okay. If I'm doing h of negative 2, that means my x-coordinate is negative 2. I'm looking for the y-coordinate. So my x is negative 2 right here. The point is right there on that axis. So, Richard, what's my y-coordinate at that point? It'd be 0, right? I'm thinking over here to my y-axis. I'm going to get 0. So you're looking where the x is. The y is your answer for that. And then my last one that I've got here is h of 0. So the x-coordinate is 0 right here. And Jamaja, what's my y-coordinate right there? Good. So negative 2 will be my value for that. Okay, questions? All right, try these on your own here. So try those from the graph there. What did you get for example 7, f of 2? Negative 1? Yes. Sorry for the long pause to make you think you had missed it right there. I was looking at negative 2 for a second. So we're looking at this point right here. Y-coordinate is negative 1. Beautiful. All right. Let's see. Caden, what about negative 3? It is not 1. That one's a tricky one because negative 3 is right here. Okay, so I believe you would be looking at this point right here, right? What does the open circle mean? Not included. So we got to keep on going up until we find the colored in circle, which is right here. And that one, you are going to have to guess a little bit on because it's not perfectly on grid lines, but it looks like it's probably 2.5 for that. So that one's tricky because you have the open and the closed circle. You want to use the closed circle for those. All right. Hector, what about number 9, f of negative 1? Nope. This one, even trickier than the one I just gave Caden. Right here, I've got a negative 1 because what I just told Caden is like we can't use the one with the open circle, right? What's the problem here for negative 1? Both of those are open circles. So it's not 1 because that's an open circle. It's also not negative 2. So is it anything? It's not. There is a word that we're going to use for this. It starts with a U. Does anybody know what it is or have a guess? Undefined. So we say that the function's undefined at that point because there's no colored in circle anywhere. Okay? So if you see like open circles, it's not a, like if it's a solid line right here like it was here, then that point's included. That's fine. But if you see nothing but open circles and see it everywhere here along where x equals negative 1, all you've got is open circles there. So that's going to be undefined. Okay? Hunter, what about negative 4, f of negative 4? It is 2. Very good. We're looking at this point right here where x equals negative 4 and our y-coordinate is 2. All right, questions there? And it is good for you to be thinking like negative 4, and then you're thinking, what is that y-coordinate? Oh, that is 2. But your answer is just the y-coordinate when they ask the question this way. So you would just type the 2 in there. Writing this down is fine, but just the 2 is your answer. All right, let's keep going, see how we're doing. Sophie, what about f of 0 for number 11? So we're looking where our x-coordinate is 0. We're going to go up or down until we hit the graph. Oh, right there it is. So our x coordinate is 0. What is that y coordinate there? 2. So 2 would be your answer for that. Okay. Cannon, what about f of -4? That'd be 1. Very good. We're looking at this point right here. Its y coordinate is 1. All right, let's see. Heston, how about f of -1? Not 1. Not undefined. -2. Because you have to look at 1 right here. You have an open circle. That open circle is not included. We don't want to use that point. But if we go down here, we do have a closed-in circle. We're looking at this point right here, and its y coordinate is -2. So you want to go up or down right there and see what you can find. And then, Fernando, what about f of 3? Yes. F of 3. There. It's 3. We're looking at this point. X coordinate right here is 3. Y coordinate is also 3. Okay. Questions on evaluating? Okay. So we're going to graph at least one piecewise function by hand for this. So this is where your cute little sticky graphs are coming in. What I want you to do, we have two functions here. We have 1/2 x minus 3, and we have x plus 1. Those are both linear functions. We're going to dig way back in our brains to Math 1. Whenever you're graphing a line, that is the form y equals mx plus b. What is that m? Slope. What is the b? Y-intercept. Okay? Y-intercept is where it crosses the x-axis, right? How do I do slope? Slope is your rise over run, or your change in y over change in x. So you're going to graph your y-intercept first, and then from that point you're going to use your slope. So you're going to go like up 1, right 2, or down 3, right 4 if it was -3/4. So let's see how you can do graphing these right here. I would use a pencil in case you mess it up, because we want to make sure yours look right before. So on your two sticky notes, on the separate sticky notes, you're going to graph, on the first sticky note, you're going to graph y equals 1/2 x minus 3. And on the other sticky note, you're going to graph y equals x plus 1. There, so graph those two on the separate sticky notes. And graph it neatly all the way out to the end of the graph. Oh, sorry about that. There you go. In front of this x, there's a 1, which is also not a fraction. I want my slope to be a fraction, right? How can I make that a fraction? I can put it over 1 right there, right? So that just means go up 1, right 1, up 1, right 1 for that. So make sure you've got those graphs draw the line. Go ahead and draw the line through there. Okay, so here's what we're going to do for our piecewise function. So everybody get your first graph, which is the 1/2 x minus 3. Let's double check to make sure that your 1/2 x minus 3 looks right. Okay? So on that y-axis, you should have a dot at -3, and then you go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, and then in the other direction, you're going down 1, left 2, so that it falls on that same line. Okay, everybody good there? All right. So, we are supposed to use this function whenever x is less than -2. Okay? We only use this whenever x is less than -2. So here is what we are going to do on our sticky note graph. -2 is right here on that graph. I am going to draw myself a dotted line, dotted vertical line right there at -2. Okay? This is my line that I need to cut. And I don't have scissors up here. Alright, so I gave you guys scissors, you'll have to share. You're going to take this graph, cut it on that vertical dotted line. You should have these two pieces. Looks like this. Right here whenever you cut it. Okay? Hold on. Okay. Alright, at -2. Vertical line right there at -2 is where we're cutting that one. Yep, vertical line right there at -2 is where we're cutting. Okay, so we are supposed to use this for x is less than -2. Which side of this graph are we supposed to keep? And which side are we supposed to throw away? Okay? Think about where your x's are. Your x's right here is -2. There's -3, -4, -5, -6, -7, -8. These numbers are less than -2, right? So the bigger piece, the one on the right side, that one is gone. Take it, crumble it up. Don't throw it yet. We'll throw them away here later. Okay? We only want to have that left side of the graph because our function tells us that's the only part that we're using, right? Okay? Now, let's look at our other graph. Let's make sure we've got that. Sticky notes. Okay? This one we're supposed to use for x is greater than or equal to -2, right? So we again need to take right here at -2. We are going to put ourselves our dotted line right there. We're going to cut this graph. On that dotted line. Okay? This time, when I cut that graph, which part do I want to keep? The left side over here, the smaller piece, or the right side? Okay, that bigger piece, that right side. So I'm going to take my left side. I'm going to crumble it up. I don't need it. Make sure you take the left side of that graph that we just had. And then I'm going to put together my two pieces. I'm going to line them back up. Now, this time, the graphs we looked at before, they all connected up, right? Do my graphs connect here? They do not. That's okay. Sometimes piecewise functions do not connect. We do have to add one more thing into this graph. It is a little hard to draw on here because we cut it. But for this function, for the 1/2 x minus 3, I was supposed to use this when x was less than -2. This does not have an or equal to sign with it, right? So if there is no or equal to sign, what kind of dot do I use? An open circle or the closed circle? Open. So what I'm going to do is I'm going to go over here. On this graph, the 1/2 x minus 3 was this graph right here. And so I need it to end with an open circle right here. So I'm going to draw an open circle at that point. Because I'm only supposed to use it when x is less than -2. However, the other one said greater than or equal to 2. And when I have a or equal to, what kind of circle do I use? Closed circle. So this is my x plus 1 graph. So right here at the end of it, I'm going to put myself a closed dot right there. And so this is what our graph of this piecewise function would look like. I like to do this activity because you can see you're literally piecing the graph together. They're called piecewise functions because you're just piecing them together. Okay, and if you just want to stick those on your notes right there, we'll throw our extra pieces away here in a second. So, questions on that? That is literally what is happening. You're not going to have to graph this by hand just because I don't have I can't put that into a quiz. It doesn't let me. I would love to, but it doesn't really let me. We'll do some delta math where we practice it a little bit, where it sort of lets you do that. But if you can do this, that gives you a picture of what's happening when you're trying to match the graphs for a multiple choice question. So the last thing that I want us to do is I want us to learn how to do this on Desmos. Okay, so it's not super easy to type these in on Desmos as a piecewise function. I'll show you two ways we can do it. I'll show you the way that we'll actually graph the piecewise function and sort of a shortcut way that'll give you an idea, but it won't let you evaluate. Okay, so we're going to start with the best way to do it. Okay, so make sure you've got Desmos pulled up on your computer there, and I want you following along. I'm going to be checking to make sure everybody's got it because you need to be able to type these in, particularly if you are not good at graphing. So I noticed when I was walking around, a lot of us have forgotten how to graph a line, right? Because we were having, hopefully when we went over it, it was coming back a little bit. But sometimes it's not all lines. Sometimes it is quadratics and cubics and different things, right? So unless you are excellent at graphing by hand and recognizing functions, it is a big help to be able to do this because Desmos does it for you. But it's not super simple on how you type this in. So when you type in a piecewise function, you're going to call it f of x or whatever letter you want to use, equals. You're going to do squiggly bracket, and I don't know why Desmos decided to do this, but you have to type in the domain first, colon, equation, comma. And then domain, colon, equation, comma. And then there might be more functions for this. So your domain, let me highlight this so we're domain 1 is this. That's your domain, right? That is x is less than or equal to 2. And then you got to do a colon, and then you would do the equation 1. So that would be this, the 5 right there. That would be your equation 1. That's this. And then you do a comma. And then you will do domain 2, right? The second part comes first when you type it in on Desmos, colon, and then the last part is the equation that goes with that. That's here. Okay? So, I want you guys to type that in on Desmos. Exactly what you need to type is right down here on the bottom. If you need to look at that, I'm going to type it in over here. Less than or equal to 2. Alright, so here is what I've got. I'm going to walk around and see if we've got that. If you're stuck and can't get it, see if your neighbor can help you. Okay, it's also, if you can't see what I've got typed in, that's about as big as I can make it there, but it's also at the bottom of that last slide. Is exactly what you need to type in. Zoom out. Right here. If it's at that, then it can hold it. There, use a colon. Alright. Alright, comma right there. That was right. Okay, right here. It thinks that's you want to do shift semicolon right there. You want to do 2 dots there, and then over here. So where you got that right there, that is the colon. It's there. See. I think you got a space between that less than or equal and equal. So what happens is like whenever you delete that space. You guys? You have to use Hey, this is good right now. Happy birthday. Oh, his birthday's tomorrow, and it's not happy birthday tomorrow. We'll sing happy birthday up there. Oh, we only sing happy birthday on his birthday, so he's got to be here. Yeah. Yeah, we have to quiet down. Yeah. All right. So, okay. All right. So, here's the good thing about typing it in like this. Now, notice it did not put dots at the end for us, but if I get all the way to the end right here, it says 2, 5, and it has a closed circle. If I click on this and go all the way to the end right here, if it'll let me, actually it won't let me, it will, like if I get to 2, it jumps up to that point. It doesn't, Desmos does not draw the open and the closed circle, so you have to know what those mean. But the nice thing about this is now if they ask us to evaluate, if I've got f of 5, it just gives me the answer. F of -1 gives me the answer. F of 7 gives me the answer. F of 2000 gives me the answer, right? So if you have it typed in, it'll evaluate at any point, and it automatically splits the graph up for you like it's supposed to, okay? So, so that is helpful. Let me show you another option because I know this is not like the easiest to type in. Another option that you have here, it will not evaluate for you if you do it this way. But another option is you can do f of x equals 5, squiggly, brackets, x is less than or equal to 2. Is it 2 on that? Okay, it'll graph that part of the graph. Then the other one, I could call it maybe g of x equals 2x minus 4, squiggly brackets, x is greater than 2. It's doing it as 2 separate functions. It means it's not going to evaluate it correctly if you try to do f of 10 or f of 7. So like if you need to plug in numbers, it won't work, but it will give you the graph correctly. So if you find that easier, especially like if you want to do each part as a separate function, you can do that as well. It just won't let you evaluate if you do that. Okay, questions? Okay, so we have got 7 minutes left.